Specimen question paper issued by UPSC. With answer: Indian Forest Service, main examination, Geology paper. I. Question: write a short note on island arc and volcanic arc. About dates or words. Answer: island arcs and volcanic arcs are important geomorphic structures related to plate tectonics. Island arcs are formed at the convergent boundary of oceanic plates. When one oceanic plate subducts beneath another, molten magma from deep within rises to form a curved chain of volcanic islands on the ocean floor. These islands are generally found parallel to deep-sea trenches. Japan, the Philippines, and the Aleutian Islands are prominent examples. Volcanic arc is a broader term, encompassing both island arcs and continental volcanic arcs. They form at the convergence of oceanic and continental plates, where the oceanic plate subducts beneath the continental plate. This results in the development of chains of volcanoes along the edge of a continent, such as the Andes. Both arcs are associated with seismic activity and active volcanism. Question: what are the geomorphic parameters used in mineral prospecting? About dates or word. Answer: geomorphological parameters are important in mineral exploration because they provide indications of surface and underlying mineralization. Weathering and erosion patterns are studied first, as hard, mineralized rocks often form raised hills, while softer rocks produce depressed landforms. River systems and drainage patterns are also important indicators. Unusual or distorted drainage patterns indicate the presence of faults or fissures, which are favorable areas of mineral concentration. Bends, alluvial fans, and coastal areas are of particular importance in the search for placer deposits. In addition, pediments, plateaus, residual hills, and laterite caps are also considered indicators of minerals such as bauxite, iron ore, and manganese. Thus, geomorphological studies are helpful in the initial identification of mineral potential. Question: write the sensors used in the IRA's Indian Remote Sensing series of satellites and their characteristics. About dates or word. Answer: the IRS series of satellites carry a variety of remote sensing sensors, which are used to study the Earth's surface. The main sensors include LIS, Linear Imaging Self-Scanning, PAN, Panchromatic, VFS, Wide Field Sensor, and OIFS, Advanced Wide Field Sensor. LIS sensors are multispectral and operate in the visible and near-infrared wavelengths. They are used in land use cover, agriculture, forestry, and geology studies. PAN sensors provide high spatial resolution, allowing the study of subtle landforms and structures. Wi-Fi and OIFS, the sensors provide wide area coverage, which is helpful in large-scale vegetation, crop monitoring, and environmental change studies. The high spatial, spectral, and temporal resolution of IRS sensors makes them extremely useful for resource mapping. Question: describe the different types of unconformities. About dates or words. Answer: an unconformity is a surface in a rock sequence that reflects long-term breaks in sedimentation, erosion, or tectonic activity. Its main types are: AIC, angular unconformity. In this, the older rock layers below are tilted or folded, while the younger layers above are nearly horizontal. This indicates intense tectonic activity. DO, disconformity. In this, the upper and lower layers are parallel, but there is a gap between them due to erosion or sedimentation. This is difficult to identify. Teen, nonconformity. When sedimentary rocks are found above igneous or metamorphic rocks, it is called an unconformity. Char, paraconformity. There is no clear erosion surface in it, but the time interval is known from the difference in fossils or age. Unconformities are extremely helpful in understanding geological history. Question: Explain the genetic classification of faults on the basis of relative movement. About dates or words. Answer. Faults are cracks in the Earth's crust that cause relative displacement of rock fragments. Based on their relative motion, faults are classified as follows. 1. Normal fault. In this, the upper section, hanging wall, slides downward while the lower section, foot wall, remains relatively elevated. It is formed due to tensional force and is commonly found in expanding areas. Though reverse fault. In this type, the upper section slides upward. It is caused by compressional forces and is common in mountain building regions. 3. Thrust fault. This is a special form of reverse faulting in which the fault plane has a very low inclination. In this, older rock fragments overlie younger rock fragments. 4. Strike, slip fault. In this, the displacement of rock fragments occurs in a horizontal direction. This can be lateral to the right or left. This classification is helpful in understanding tectonic forces. Question 2. A. Briefly describe the Earth's interior in terms of compositional layering and seismic discontinuities. Answer with a suitable labeled diagram. Answer. The Earth's interior is primarily studied based on its structural layers and the behavior of seismic waves. According to this, the Earth is divided into the following parts. 1. Compositional layers. I. Crust Kissy Smiley. It is the Earth's outermost and thinnest layer. Continental crust is composed primarily of silica plus aluminum, while oceanic crust is composed primarily of silica plus magnesium. Its average thickness ranges from 570 kilometers to mantle Kissy Smiley. This layer, located beneath the Earth's crust, extends approximately 2,900 kilometers. It is composed primarily of silicate minerals containing magnesium and iron. It consists of the upper mantle and the lower mantle. 3. Core. This is the Earth's innermost core, composed primarily of iron and nickel. Hence the name Ni plus Fe. The core is divided into the outer core, liquid state, and the inner core, solid state. Though seismic discontinuities. I. Mohorovi-IC discontinuity. This is the boundary between the crust and the mantle, where the speed of seismic waves suddenly increases. 2. Gutenberg discontinuity Kissy Smiley. This is the boundary between the mantle and the core at a depth of about 2,900 kilometers. S. Waves die out here, suggesting the core is liquid. 3. Lemon discontinuity Kissy Smiley. It is the boundary between the outer core and the inner core, indicating that the inner core is solid. Conclusion. Composition and state, solid-liquid, of the Earth's interior can be understood, which is very important in the study of geology. Question 2. B. The major drainage patterns and the factors controlling them. Answer. Drainage patterns refer to the systematic shape and arrangement of rivers and their tributaries in a region. These patterns are controlled by geological structure, topography, and rock formations. 1. Major drainage patterns. I. Dendritic drainage pattern Kissy Smiley. This is the most common pattern. Rivers spread out like the branches of a tree. It occurs in areas with homogeneous rocks and gentle slopes. 2. Parallel drainage pattern Kissy Smiley. In this, rivers flow parallel to each other. It develops in areas with steep slopes. 3. Trellis drainage pattern. In this, tributaries meet the main river at right angles. It is found in folded sedimentary rocks and folded mountain regions. 4. Rectangular drainage pattern. It develops in fault and joint-controlled areas, where rivers turn at right angles. Radial drainage pattern. In this, rivers flow outward from a central elevation. This is found in volcanic cones and dome-shaped structures. 6. Centripetal drainage pattern. Rivers flow from all sides into a low area or lake. It develops in inland basins. Though factors controlling drainage patterns. I. Rock structure. The hardness of rocks, faults, joints and direction of layers affect the drainage pattern. 2. Topography Kissy Smiley. Height and shape of the land determine the direction and pattern of rivers. 3. Climate. The amount and intensity of rainfall controls the drainage density and pattern. 4. Geological history. Folding, faulting and tectonic activities affect the drainage system. Conclusion. Drainage patterns help in understanding the geological structure and topography of an area and have special importance in geology and geomorphological studies. Question 2. C. A fold calculated? List the assumptions used in the calculation. Answer. Calculating the depth of a fold. The depth of a fold refers to the maximum vertical distance between the anticline crest or syncline trough and the axial plane datum. It is calculated primarily based on data from a geological map, contours, and dip. Method of calculation Kissy Smiley. The height of the exposed points of the same rock layer on both the limbs of the fold is determined. The depth is calculated using trigonometric method based on the inclination angle, dip, and horizontal distance of that rock layer. The formula is commonly used. Depth horizontal distance tan, incline angle. If contour map is available, fold depth is also estimated through contour difference. Key assumptions used in the calculations. 1. The thickness of the rock layer is assumed to be uniform. 2. The folds are considered to be regular and symmetrical. 3. The inclination angle is assumed to be constant throughout the area. 4. After the formation of folds, the effect of erosion is considered negligible. 5. The rock layer is considered to be continuous and without faults. 6. Measurement is done from a flat horizontal datum. Conclusion. Calculating the depth of folds under these assumptions is helpful in geostructural analysis and helps in understanding the internal structure and evolution of folds. Question 3. A. What are seismic waves? Describe in detail the different types of seismic waves. Answer. Seismic waves. Seismic waves are energy waves generated within the earth by earthquakes, volcanic eruptions, or tectonic activity and propagate in all directions. Studying these waves helps understand the structure of the Earth's interior. Seismic waves are mainly divided into two categories. A. Internal, body, waves. These waves are transmitted into the interior of the Earth. I. Primary waves, P waves. These are also called longitudinal waves. These are the fastest moving waves. It can travel through all three mediums, solid, liquid and gas. The vibration of the particles is parallel to the direction of the wave. Earthquake recordings arrive first at the station. 2. Secondary waves, S waves. These are called transverse waves. Their speed is less than that of P waves. Transmits only in solid media. They do not circulate in liquid medium, which proves that the outer core is liquid. The vibration of the particles is perpendicular to the direction of the wave. Though surface waves. These waves travel along the Earth's surface and are the most destructive. I. Love waves. In these, the vibration of particles occurs in the horizontal plane. These cause serious damage to buildings and structures. Transmitted only on solid surfaces. 2. Rayleigh waves. Is elliptical like sea waves. These move the land up and down and back and forth. Most of the damage caused by earthquakes is caused by these waves. Conclusion. The study of seismic waves is not only helpful in understanding the nature of earthquake, but is also a major means of obtaining information about the internal composition and structure of the Earth. Question 3. B. Describe the different types of aerial photographs. Comment on their usefulness in geological studies. Answer. Aerial photographs are images taken from above the Earth's surface by aircraft or drones. In geology, they are used to study topography, rock formations, and geomorphic features. 8. Types of aerial photographs. I. Vertical aerial photographs. The camera is placed perpendicular 90 degrees to the Earth's surface. Very useful for mapping. Measurements are more accurate. The exact location of geological structures is known. 2. Oblique aerial photographs. The camera is placed at an angle to the surface. Topography and heightlowness are clearly visible. 2 types. A. Low oblique. The horizon is not visible. B. High oblique. Horizon is visible. 3. Stereo photographs. 2 partially overlapping photographs. Provides 3-dimensional 3D views. Helpful in studying slope, height and depth. Though useful in geological studies. 1. Identification of rock structure, folds, faults, joints. 2. Study of drainage patterns and river systems. 3. Identification of geomorphic features such as plateaus, valleys, fans, etc. 4. Helpful in mineral and oil exploration. 5. Identification of landslide, erosion and weathering areas. 6. Quick survey of inaccessible and extensive areas. Conclusion. Aerial photographs are a vital tool in geological studies. They enable a comprehensive and accurate study of the Earth's surface and structural features, while saving time, labor, and cost. Question. What evidence of strain is found in deformed rocks? How is the amount of strain calculated? Answer. A. Evidence of deformation in deformed rocks. A. Folding of layers. 2. Faulting. 3. Changes in rock structure, foliation and lineation. 4. Elongation flattening of mineral particles. 5. The original round particles become elliptical, formation of strain ellipsoid. 6. Deformed form of fossils or pebbles. 7. Shear zones and microfractures. 8. Change in grain size by recrystallization. B. Calculation of the amount of strain. 1. Length conversion method by comparing the initial and final lengths. 2. Strain ellipsoid method by the ratio of the axis of the particles. 3. RF method from the axis ratio and orientation of ellipsoidal particles. 4. Flint diagram ratio of major, middle and minor axes. 5. Shear strain calculation from angular deviation and displacement. Conclusion. Structural and mineralogical changes in deformed rocks are clear evidence of deformation, and the amount of deformation is estimated by various geometric and graphical methods. Question. What is a volcano? Briefly describe elevated and depressed volcanic topography. Answer. Volcano is a geomorphic structure through which magma, lava, gases, and ash emerge from the Earth's interior onto the surface. Elevated volcanic topography. 3. 1. Volcanic cone, a conical high structure made of accumulation of lava, ash and volcanic materials. 2. Lava plateau, flat and elevated land formed by extensive flow of liquid lava. 3. Dome, a circular high structure formed by the slow outpouring of thick lava. Depressed volcanic landforms. 3. 1. Crater, a ball-shaped depression around the mouth of a volcano. 2. Caldera, a huge depression formed by massive eruption or summit collapse. 3. Lava crater volcanic lake, a depressed structure formed by water filling a crater or caldera. Question: discuss the applications of remote sensing in geology. Answer: remote sensing is widely used in geology in the following areas. 1. Geomorphological study, identification of mountains, plateaus, plains, river systems, erosion and depositional forms. 2. Rock and structural mapping, study of faults, folds, joints, lineaments and rock boundaries. 3. Mineral exploration, identification of mineral zones, determination of ore belts and alteration zones. 4. Groundwater exploration, identification of groundwater potential areas, aquifers and recharge areas. 5. Volcanic studies, observation of active volcanoes, lava flows and thermal anomalies. 6. Landslide study, identification of landslide-prone areas and risk assessment. 7. Seismic studies, analysis of areas related to active faults and plate tectonics. 8. Coastal and marine geology, study of shoreline changes, deltas, lagoons and marine sediments. 9. Environmental geology, assessment of land degradation, desertification and environmental changes. 10. Geodisaster management, monitoring and early warning of disasters like floods, volcanic eruptions, landslides. Thus, remote sensing is very useful as an effective and modern technique in geology. Question: 15 marks. Explain the relation of cleavage and schistosity with major geological structures. Answer: 1. Meaning of cleavage. Break easily along weak planes. It develops primarily due to low-grade metamorphism and tectonic stress. Meaning of schistosity. Schistosity is a planar structure developed in medium to high-grade metamorphism, in which platy minerals such as mica are arranged in parallel. 3. Relationship between cleavage, schistosity and major structures. A. Relation to fold. Cleavage generally develops parallel to the axial plane of the fold. This is called axial plane cleavage. The direction of cleavage varies in the limbs of the fold. Schistosity is also often parallel to the axial plane of the fold, especially in schists. B. Stress and deformation. Both cleavage and schistosity develop perpendicular to the maximum compressive stress. Cleavage is formed under low strain conditions and schistosity is formed under high strain and high temperature pressure conditions. C. Relation to fault. Cleavage and schistosity are more pronounced due to intense stress around the fault zone. New cleavages may develop from fault-induced shearing. D. Regional metamorphism. In regional metamorphism, slaty cleavage develops first. As the intensity of metamorphism increases, this cleavage transforms into schistosity. This sequence represents structural evolution. E. Relationship according to rock type. In slate, cleavage chief. In phyllite, phylitic cleavage. In schist, schistosity. In gneiss, gneissic banding, where the schistosity weakens. 4. Conclusion. Cleavage and schistosity are both major planar structures that are closely related to folds, faults, stress direction, and the intensity of metamorphism. Cleavage indicates low-grade metamorphism, while schistosity indicates high-grade metamorphism, and together they are extremely helpful in understanding the tectonic history of a region. Question: describe the evolution of suture in Ammonoidea. Answer: the suture line is a line formed at the junction of the shell septa and the outer shell. Its evolution is considered extremely important in paleontological studies. Sutures evolved from simple to complex forms over time. Early ammonoids have goniatitic sutures, in which the lobes and saddles are simple, smooth, and without subdivision. This type is found primarily in the Devonian and Carboniferous periods. Later, the ceratitic suture developed, in which the lobes are denticulated while the saddles remain smooth. This type is characteristic primarily of the Triassic period. Finally, the most advanced stage, the ammonitic suture, developed, in which both the lobes and saddles were highly complex, branched, and subdivided. It was widespread during the Jurassic and Cretaceous periods. Thus, the evolution of sutures in Ammonoidea shows a progression from simple to highly complex structures, which is helpful in determining their biological evolution and dating. Question: Lithostratigraphic classification. Describe its various rank terms. Answer: Lithostratigraphy is the classification of rock strata based on their lithology, texture, color, mineral composition, and regional extent. It prioritizes physical properties over age. Lithostratigraphic units are mainly classified into the following ranks. 1. Supergroup. This is the highest order of lithostratigraphic classification. It includes several related groups. It is used when formations span a very wide area. Example: Vindhya supergroup. 2. Group. A group is a group of several related formations that share some common lithological characteristics. Example: Kudpa group. 3. Formation. It is the fundamental and most important unit of lithostratigraphy. Its rock structure is clear and can be shown on a map. Example: Bhandar limestone formation. 4. Member. A subdivision of a formation is called a member. It is identified by distinctive lithology or local features, but this is not always regionally extensive. 5. Bed. It is the smallest unit of lithostratigraphic classification. Beds are generally composed of a single type of rock and have a small thickness. Conclusion: Comparing and geological mapping rock strata. It studies rock units sequentially from supergroups to beds. Question: What is the Pliocene-Pleistocene boundary problem? Explain its main controversial points. Answer: Is a significant controversy concerning the demarcation of the Neogene and Quaternary periods in the geological timescale. There has long been disagreement about the definition of this boundary. Its key points are: 1. Definitional problem. The Pliocene and Pleistocene were initially distinguished by climatic changes, particularly the onset of ice ages, but this criterion was not found to be universally consistent. 2. Climate-based differences. Some geologists believe that the Pleistocene began with widespread glaciation, while others believe that smaller and temporary glaciations also occurred at the end of the Pliocene. 3. Fossil evidence. Mammals, especially elephants, horses, and human ancestors, show gradual changes in their evolution, making it difficult to draw clear biological boundaries. 4. Magnetostratigraphy. An attempt was made to determine the boundary based on magnetic polarity reversals, but their records were found to be different in different areas. 5. International standardization. Eventually, the International Union of Geologists, IUGS, placed the beginning of the Pleistocene at about 2.58 million years ago. Step which solved this problem to a large extent. Conclusion: The Pliocene-Pleistocene boundary problem arose primarily due to inconsistency in climatic, fossil, and stratigraphic criteria. Modern dating techniques and international consensus have now more clearly defined this boundary. Question: Describe the various aspects of earthquake-resistant structures. Answer: Earthquake-resistant structures are those designed to withstand seismic forces and minimize damage to life and property. Its key aspects are: 1. Selection of suitable site. Asterisk. For an earthquake-resistant structure, it is essential to select solid, stable, and crack-free rock or soil. Loose soil and fault zones should be avoided. Though, structural design. The design of the building should be simple, symmetrical, and balanced so that the impact of seismic waves is distributed evenly. 3. Ductility. The structure must have flexibility so that it can bend and absorb energy rather than break. 4. Strong foundation. Deep and strong foundations reduce the impact of seismic waves and increase the stability of the structure. 5. Proper construction materials. Reinforced concrete, steel and lightweight construction materials makes the structure safer. 6. Energy dissipation technique. Earthquake energy is reduced using techniques such as shock absorbers, base isolation and dampers. 7. Adherence to construction standards. Asterisk. It is very important to follow earthquake-resistant building codes and standards. Conclusion. Various aspects of earthquake-resistant structures, such as site selection, design, materials, and modern technology, make the structure safer and significantly reduce the impact of an earthquake. Question: explain the importance of groundwater chemistry. Answer: ions and gases dissolved in groundwater. Its importance is evident in the following points. 1. Determination of drinking water quality. Asterisk. The study of groundwater chemistry reveals the amount of dissolved salts, hardness, fluoride, nitrate, arsenic, etc. in the water, which determines the suitability of drinking water. Though, assessment of health effects. Harmful elements present in groundwater can have serious effects on human health. Chemical analysis makes it possible to prevent diseases. 3. Importance in agricultural use. Salinity of groundwater for irrigation, sodium absorption ratio, SIR, etc. is necessary for the fertility of crops and soil. 4. Industrial uses. The quality of water used in industries is determined by groundwater chemistry to avoid problems of scaling, corrosion, and pollution. 5. Identification of groundwater flow and origin. Chemical composition provides information about the origin, flow path, and recharge areas of groundwater. 6. Identification of pollution. Kiss Smiley. Groundwater chemistry helps in identifying pollution sources and controlling them. 7. Water management and conservation. Based on chemical data, plans are made for sustainable use and conservation of groundwater. Conclusion: is essential for drinking water security, agriculture, industry, health, and environmental protection, and it plays an important role in the effective management of groundwater resources. Question: describe the morphological structure of echinoids in detail and explain it with suitable diagrams. Answer: echinoids are marine invertebrates belonging to the phylum Echinodermata, including sea urchins and sand dollars. Their morphological characteristics are as follows. Ech. General shape and symmetry. The body of echinoids is generally round, semicircular or circular. Pentamerous symmetry is often found in these. Though. Test. The body's hard exoskeleton is made of calcium carbonate plates called testes. These plates fuse together to form a strong structure. 3. Ambulacral and interambulacral region. There are 5 ambulacral regions on the test, which contain the openings for the tube feet. Between these are interambulacral regions. 4. Spines. The surface of the test is covered with movable spines, which aid in protection, movement, and food collection. 5. Peristome and periproct. The mouth is located on the lower surface, called the peristome. The anus is located on the upper surface, or posterior, called the periproct. 6. Apical system. The upper surface bears genital pores and eye plates, which form the apical system. 7. Aristotle S. lantern. It is a complex chewing apparatus which is found inside the mouth and helps in chewing food. 8. Tube feet. Tube feet connected to the water vascular system help in respiration, locomotion, and food collection. Conclusion. The morphological structures of echinoids, such as the hardened test, ambulacral arrangement, spines, and Aristotle's lantern, make them well suited to life in a marine environment. Question. Discuss the Devonian stratigraphic succession of the Garhwal Himalaya. Answer. The Devonian rock series in the Garhwal Himalayas form a significant part of the Tethesian Himalayas. This sequence is composed primarily of marine sedimentary rocks and is rich in fossils. The Devonian stratigraphic succession can be described as follows. 1. Condition delivery. Devonian rocks are well developed in the Badrinath, Joshimath, Niti region in the Garhwal Himalaya and lie above the Silurian and below the Carboniferous. 2. Lithology. It consists mainly of limestone, dolomite, shale, slate, and sometimes quartzite. Limestone is often fossiliferous. 3. Tier order, bottom to top. Lower Devonian shale, slate and thin limestone. Middle Devonian, coarse limestone and dolomite. Upper Devonian shale, limestone and fossiliferous strata. 4. Fossil material. In this sequence, fossils of brachiopods, corals, trilobites, gastropods and stromatoporoids are found in abundance, which indicate marine deposition. 5. Deposition environment. During the Devonian period, the Garhwal Himalayan region was located in a shallow marine environment where carbonate rocks were formed under calm conditions. 6. Importance. This layered succession is very helpful in understanding the geological evolution of the Himalayas, the expansion of the Tethys Sea, and the environment of the Paleozoic period. Thus, the Devonian stratigraphic succession of the Garhwal Himalaya is of special geological importance due to its rock composition, fossils, and structural features. Question. Describe the different types of dams and the forces acting on them. 15 marks. Answer. A. Types of dams. Dams are mainly classified into the following types on the basis of their structure, construction material, and working method. 1. Gravity dam. This dam resists the pressure of water under its own weight. It is usually made of concrete or stone. Its foundation must be very strong. 2. Arch dam. Transfers water pressure to the valley walls, abutments. It is suitable for narrow valleys. 3. Buttress dam. Consists of a thin slab wall supported by buttresses from behind. It requires relatively little construction material. 4. Earth dam. It is made from clay, sand, and gravel. It has a wide base and is useful for large reservoirs. 5. Rock-fill dam Kissy Smiley. It uses large stones and has a waterproof core inside. It is useful in seismic areas. 6. Composite dam. It combines the characteristics of two or more types of dams, such as gravity plus earth dam. B. Forces acting on the dam. For the stability and safety of a dam, it is very important to study the forces acting on it. 1. Water pressure. The horizontal pressure of the reservoir is exerted on the dam wall and increases with depth. 2. Self-weight. The dam's own weight helps to keep it stable and resists water pressure. 3. Uplift pressure. The upward pressure of water from beneath the foundation of a dam, which can destabilize the dam. 4. Earthquake force. During an earthquake, the dam experiences horizontal and vertical shocks. 5. Silt pressure. The silt deposited in the reservoir exerts additional pressure on the dam wall. 6. Wave pressure. Waves generated by strong winds impact the upper part of the dam. 7. Thermal stress. Changes in temperature cause contraction and expansion of the dam material. Conclusion: the type of dam depends on the topography, valley width, construction materials, and geological conditions. Proper study and balance of all forces acting on a dam is essential for its safety and longevity. Question: discuss the mammalian fossil record of the lower and upper Sivalics. Also, comment on the reasons for the paucity of fossils in the boulder conglomerate formation of the upper Sivalics. Answer: the Shivalik group is an important new tertiary sedimentary sequence developed in the Himalayan front, world-renowned for its rich mammalian fossils. It is generally divided into the lower, middle, and upper Sivalics. Lower Shivalik. The lower Sivalics are composed primarily of sandstone, shale, and siltstone. This period saw humid warm climate and dense forests, leading to a high mammalian diversity. Major mammalian fossils found here include early elephants, rhinoceroses, pigs, deer, horses, and carnivorous mammals. This fauna indicates environmental stability and favorable living conditions. Upper Shivalik. Coarse-grained sandstone, pebble shales, and boulder conglomerates predominate in the upper Sivalics. The number and diversity of mammalian fossils here decreases compared to the lower Sivalics. Nevertheless, remains of some advanced mammals, such as developed elephants, horses, and bovids, have been found, suggesting environmental changes and the development of open grasslands. For the lack of fossils in the boulder conglomerate of the upper Sivalics. 1. Extremely high energy depositional environment in which fossils cannot survive. 2. Destruction of fossils due to rapid erosion and transportation. 3. Less possibility of preservation of organic remains among coarse pebbles and boulders. 4. Environmental instability and habitat destruction due to Himalayan uplift. 5. The climate became drier and colder, leading to a decline in mammalian diversity. Conclusion: the lower Sivalics are extremely rich in mammalian fossils, while the upper Sivalics, especially the boulder conglomerate, are poor in fossils due to high energy deposition, rapid erosion, and changing environmental conditions. Question: describe in detail the stratigraphy of Aravalli supergroup. Answer: the Aravalli supergroup is one of India's oldest Proterozoic rock formations, extending primarily into Rajasthan, the Aravalli Range. Its age is estimated to be approximately 2000 to 1800 million years. This supergroup is composed primarily of sedimentary and volcanic rocks that underwent metamorphism. The Aravalli supergroup is generally divided into two major parts. 1. Lower Aravalli supergroup. It lies unconformably on the bedrock, basement, main rock groups, quartzite, conglomerate, phyllite, slate, dolomite. Key features: deposition in terrestrial and shallow marine sedimentary environments, coarse-grained sediment, signs of early tectonic activity. Though Upper Aravalli supergroup. It is situated successively on the lower Aravalli group. Main rock groups: carbonate rocks, limestone, dolomite, phyllite, schist, quartzite, volcanic intrusions, basic and ultrabasic rocks. Key features: marine sedimentary environment, predominance of chemical sedimentation, more advanced metamorphosis, stratigraphic sequence of the Aravalli supergroup, bottom to top. 1. Basement granite and gneiss. 2. Lower Aravalli group. 3. Upper Aravalli group. Economic importance: copper, lead, zinc, silver ores, marble and building stone. Conclusion: the Aravalli supergroup is of great importance in Indian geology because it provides clear insights into the tectonics, sedimentation, and mineral resources of the early Proterozoic period. Its stratigraphy helps us understand the ancient geological history of India. Question: what are the different types of groundwater wells? Discuss the characteristics of each well. Answer: different types of wells are used for exploitation of groundwater, the types and characteristics of which are as follows. Ek, open well. An open well is dug to the surface water level. It has a large diameter and a shallow depth. It draws water from an unconfined aquifer. Because it is dependent on rainfall, it becomes deficient in water during the summer. Do, tube well. This is a deep well with a narrow diameter dug by machine. It provides continuous water supply from a greater depth. It is extremely useful for agriculture and drinking water supply. 3. Artesian well. The water in this well is under pressure. When the water rises to the surface on its own, it is called a flowing artesian well. A pump is not required. 4. Driven well. This is a small diameter well drilled into the ground in areas with loose sand or gravel. It is shallow and has a limited water content. Panch. This well consists of it is useful for supplying water to large cities. Conclusion. Different types of groundwater wells are selected based on the geological structure, the nature of the aquifer, and the water requirements. And limitations. Question. Briefly describe the evolution of brain capacity in hominidae. Answer. The evolution of brain capacity in the hominidae family has been gradual and continuous. Early hominids had small brains, but these brains grew over time. A brief summary of this is as follows. एक Australopithecus. दो Homo habilis. Brain capacity increased to about 600, 700 cubic cm. Simple tools began to be used. 3. Homo erectus. Brain capacity reached at approximately 800, 1100 cubic cm. The use of fire and better tools were developed. 4. Homo neanderthalensis. The brain capacity was approximately 1400 to 1600 cubic cm, larger than that of modern humans. 5. Homo sapiens. The average brain capacity is about 1300 to 1400 cubic cm. Complex language, art, culture, and advanced social organization developed. Conclusion. The evolution of brain capacity in hominids is linked to the development of body structure, intelligence, language, tool-making, and social behavior. This evolution distinguishes humans from other species. Question. Describe the structure of the western and eastern continental margins of India. 15 marks. Answer. A. Western continental margin of India. 1. It is a passive continental shelf located towards the Arabian Sea. 2. Its origin is related to the breakup of Gondwana and the separation of India and Africa. 3. It has a narrow continental shelf, about 50-80 kilometers, especially along the Konkan-Malabar coast. 4. The continental slope is steep and deep sea plains are developed beyond it. 5. Many faults and host-gruben structures are found parallel to the coast. 6. The Lakshadweep Ridge is a major structural feature. 7. Deccan Trap extends to coastal and offshore areas. 8. Mumbai offshore basin has thick sedimentary layers and petroleum potential. 9. Evidence of volcanic activity is comparatively more common. B. Eastern continental margin of India. 1. This is also a passive continental margin located towards the Bay of Bengal. 2. Its origin is associated with the separation of India Antarctica Australia. 3. The continental shelf is wide, up to 100-200 kilometers here. 4. The continental slope is relatively gentle. 5. Large river systems, Ganga, Godavari, Krishna, Kaveri, have caused extensive sediment accumulation. 6. Bengal fan is the world's largest deep-sea fan-shaped deposit. 7. Krishna Godavari, Kaveri, and Mahandi basins are the major sedimentary basins. 8. Volcanic rocks are absent or very little present. 9. Fault structures are relatively few and simple. C. Comparative findings. 1. The western shore is narrow, steep, and volcanic in nature. 2. The eastern shore is broad, gently sloping and covered with thick sedimentary layers. 3. Both the coasts are inactive, but their structural and sedimentary characteristics are different. Question. Briefly explain the genetic classification of water. Also, comment on the different types of aquifers. Answer. A. Genetic classification of water. The basis of genetic classification is the origin of water. Under this, water is divided into the following types. Ek. Meteoric water. This water comes to Earth from the atmosphere in the form of rain, snow, or dew. This is the main source of groundwater. Rivers, lakes, and most groundwater fall into this category. Do. Juvenile water. This water originates from the Earth's interior, magma. Volcanic activity is an example. It is not directly connected to the surface water cycle. 3. Connate or fossil water. This water becomes trapped in sedimentary rocks during their formation. It is often saline and is found in deep sedimentary basins. B. Types of aquifers. Aquifers are ground layers that are capable of storing and flowing water. The main types are Ek. Unconfined aquifer. It has no impermeable layer at the top. Its upper level is called the water table. Recharge occurs directly from rainfall. Do. Confined aquifer. It is surrounded by impermeable layers above and below. The water in it is under pressure, and when a well is dug, the water can rise spontaneously. 3. Semi-confined or leaky aquifer. It has a partially permeable layer at the top or bottom, which allows limited amount of water to seep through. 4. Perched aquifer. It is a temporary water reservoir located above the local impermeable layer, which is found above the main water table. Conclusion. The genetic classification of water explains its origin, while the classification of aquifers helps understand the nature of groundwater storage and flow. Studying both is crucial for water resource management. If you found this video helpful, please like, share, and subscribe. See you soon. UPSC Government. Jobs batch starting soon. Online live classes, unlimited access for limited period. Hindi English medium. Updated study material. Affordable fees. Regular counseling and discussion. Join now, limited seats. Contact +917668008186 9410483500